Hi, we are from Group 2 from class AS1201A and we will be presenting about friction force. Now, I'm going to introduce our group members. The members are Azan Izati, Karsten Emmanuel, Felicity Sonia, Joanna Claudia, and Nur Ain Shamimi. The objective of this experiment is to determine the coefficient of static friction of different surfaces.
Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is traveling. Force exists when the object accelerates or undergoes a change in its velocity. Body at rest or in equilibrium exhibit resultant force, or the sum of all forces acting on that body is zero. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on an object on Earth is approximated as Fg is equal to mg, where m is the mass of the object and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as its weight. Normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. Figure 5.1 shows the body diagram of a mass m lying on a horizontal surface, where the normal force N is equal in magnitude to the gravitational force mg. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction: static and kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of a static frictional force is given by Fs max equal to nu s n, where is nu s the coefficient of static friction and n is the normal force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface it is lying upon. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by Fk equal to nu kn, whereas nu k is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plotted data, the coefficients of static friction will be obtained.
Apparatus. For this experiment, the apparatus that we will use are wooden block, 50 gram and 100 gram masses, 10 Newton spring scale, string, and tabletop.
The procedure. Step 1. The mass of wooden block was measured and recorded as n. Step 2. The apparatus as shown in figure 2 was set up. Step 3. The tabletop was stable and horizontal to the ground. Step 4. The spring scale and the wooden block was attached with a string. Them were placed horizontally on the tabletop. Step 5. A M equal 50 gram mass placed on the wooden block. Step 6. The spring pulled slowly. Once the block started to move, the spring scale reading being recorded. The value as Fs recorded and tabulated in Table 1. Step 7. Step 4 until 5 was repeated for 3 trials. Step 8, another 50 gram mass was added on the wooden block, and the step 5 to 6 repeated. The step repeated until the total of M equal to 100 grams mass was on the wooden block. Step 9. The data was tabulated in Table 2.
Result. Here is the result for our friction force experiment. For this experiment, we are using two masses on the same surface, which is horizontal plane. The first table we are using 100 gram mass, and the second table we are using 50 gram mass. The first column of the first table is the mass of the wooden block. The second column is the total mass of wooden block and the 50 gram mass. The third column is the weight, and we calculate it by using total mass times the gravitational acceleration. The same thing goes for the second table, except for the total mass and weight. For the reading, we did it for 3 times for both tables so that we can get the average reading.
Objective achieved, we are able to determine the coefficient of static friction of different surfaces.